Today's session, we'll first discuss some problem together. Which rank will win? So let's start by this problem and try to analyze it together. Okay, able to see the screen, right? This we call it interlock. This kind of problem that you can see here, we call it interlock. So who would help me analyze this problem? The interlock problem. So practical application of relay logic or lat diagram is in control systems where we want to ensure two incompatible events cannot occur at the same time. Assuming you should never have LED 1 and LED 2 or LED 1 and LED 2. You cannot have them on at the same time. Assume you have a problem, you have a situation on which those two events are incompatible, cannot occur at the same time. So what we basically do, this is a general rule, the output of the second event, we put it as an input or in the rank of the first event, and also the output, this is the output of the first event, we put as an instruction or in the rank of the second event. Alright, and in this case they will never occur at the same time. Do you agree that's how we do, or you think no, it's not possible? It's possible even with this problem that the two events happen at the same time. Do you think they may happen at the same time in this situation, or they will never happen at the same time? Event 1 and event 2, LED 1 and LED 2. What do you think? They will never happen at the same time, right? Okay, so that's it. Just you do it this way. This we call it interlock. Okay, this situation we call it interlock. You know, in programming in general, even when you do C or whatever, there is some language, some practical things we always remember because we may use in some problems. Okay, in case we need interlock, so we know what we should do now. Later on, as in bucle 4, for example, loop 4, sometimes you put two loop, one inside each other, right? So this is in programming. Here you will find later that there is some kind of problems that we need to remember them. So in order to don't rethink about them each and every time. So if we want to solve a problem in which this situation will happen, so we use them directly. Like as I said, two loop 4 inside each other, for example, in programming. So we will see also some similar situation later on in the course. It's like some situation, some application which we need to remember them always. I'll give you one example and we keep it for you now. Later on we'll discuss. When you want to do flashing a light, or we call it blinking. Okay, when we have a light, we want to have it on off, maybe on for 1 second, off for 1 second. Okay, flashing a light we want to do using lat logic. So this is something we remember always. Okay, in any situation, any big problem on which I have one output, I need to flash it, so I apply it directly. So this rule we will see in later practice. And now we learned this one. This is, we call it interlock. Any question regarding the interlock before switching to double coil problem? Do you have any question? Yes, no?
لا لا.
Okay, good. Um double coil problem. But the problem is simple. Okay, here, well, I have two rang. Switch 1 connected to LED 1 and switch 2, let me write it, connected directly, maybe in red if you wish. So connected directly to a LED 2. So I have two switches, one switch and one output, LED 1, and switch 2 also connected to same output. Okay, look at them, same output. Able to see this is LED 1 and this is LED 1. Able to see, and they are connected to two switches directly. Only one instruction I have in each rank. Switch, examine if closed, and examine if closed instruction. All right. So my question to you is the following: which rank will control the output and why? Is the question clear first? Clear first.
قصدك which switch يعني؟
Uh, I'm saying which rank, but yeah, at the end here because you have only switch on the rank, you have only switch. I agree with you. So which is which in this case? But maybe if you have more
Which
instruction,
one has more priority?
yeah, which one will control the output? What do you think?
Switch 1 will have more priority than switch 2.
Okay. Hussam said which rank 1 have more priority than rank 2. Switch 1. Everybody agree with Hussam? Or you have different opinion? So now I have switch 1 connected to your light 1 and switch 2, which is in the second rank, connected to the same output, same LED. So do you all agree with Hussam opinion that rank 1 has more priority? Rank 1 will win. So it means, Hussam, it means like if you close switch 1 and you open switch 2, the light will be on. It's the same light. I mean, if I close it here and I open here, if the first rank will win, means the light will be on. Okay. If I close both, of course it will be on. If I open both switches, but I have four situations for switches. So switch 1 and switch 2, they have the four situation, or both are 0, or one of them is on, or both are on. I mean, if both are on, for sure LED 1 will be on. If both switches are off, of course LED 1 will be off. Now, if switch 2, so according to Hussam, let me correct me if I'm wrong, that's what you said, Hussam. Suzanne, if switch 1 is on and switch 2 is off, LED 1 will be on. And right? And if switch 1 is off and switch 2 is on, then LED 1 will be off because this rank will win.
لا, it will be on.
Okay, so then here is on, right?
Yes.
So in this situation, rank 1 will win. Okay, so that's what Hussam said. Do you agree with him? Or you have another thought? What do you think? What others they think? Is there anything wrong or you all agree with this scenario?
دكتور هون على الزيرو 1 المفروض ما بتدور للاي دي 1
Okay,
لأنه ما بيوصل له من مطرح.
on 0 1 this situation يعني when switch 1 is open and switch 2 is closed, LED 1 should be off, right وليد?
لا it will be off. ما
Yeah.
الأوبن circuit doesn't force off.
Okay. I mean, it's his opinion. We have freedom in this class. Okay, it's his opinion. No, I'm laughing. Okay. So what others they think? I mean, do you have different opinion, or you think? Let's see them in what this problem is about. Open. I call it double coil, right? So that's the problem, right? That's it. So I will download it, and then I run it. Okay. So I have two switches. It seems my switch one was on. Okay, so I have two switches and same LED. LED one, which is this light. Able to see my screen, right? So what I will do, maybe if you wish, I can minimize it a bit, so we can see both. We can see both here and there. So now I'm in the first situation. Both are off. We agree. So then we are fine with it. Okay. So we are fine. This is the first one. Is if I want to correct it black. So the first one is correct here. So what about the second situation where switch 1 is on and switch 2 is closed? 0 1. So the light is on. Then this is the correct one.
دكتور بس فينا نرجع نجرب الكيس 1 لما السويتش 1 is on والسويتش 2 is off.
Switch 1 is on. We will try it now. So now this is case 3. Switch 1 is on. This is switch 1 is on and switch 2 is off. So the light is
هن الاثنين عندهم نفس الادرس.
yes, it's same light.
Okay.
So then here what happens? The light
The
is
LED will be off
off.
because last rung wins.
Because who said last rank when?
Me, doctor.
Haider. Yes, Haider. Okay. And if we are in the last situation, of course, if both are on, then it will be on. So then you answer it this way. Last rank, which rank will control the output? Then last rank will control the output. Last rank will control the output. Last rank will control the output. So if the last rank is on, then the output is on. If the last rank is off, the output is off. So not the first rank that controls the output actually. It's really the last rank. If it is off, whatever last first rank is, the output is follow last rank. So now the second question is why? If you understood it, then we jump to the second question. Do you have any question regarding it before jumping to why? Why do you think this?
Because the program scans each rung by rung from up to down.
Excellent. Yeah, excellent. So yeah, that's exactly why. Because the program, the scanning cycle, if you remember when I was talking about scan cycle, start by looking at the input data, then execute it, then send to the output. Take an input, execute it, store it in the, so looking to the input from a data input file, from data, the data input file, and putting the output result, the result of the logic operation, they put it in a data output file. Then later, whatever in the data output file will be sent to the output module interface. So that's how the program works. And during the execution of the program, yes, it's executed from up to down, from left to right. That's the execution. So they start first, they collect all the input situations, so they know what they are. Then they start execute it in here. So they find LED1 is Q00. In this case, the address is Q00. They put it 0, assuming we are in the case 0. Then, if that's the situation, then switch 2 is closed. So it is 1. Then they go and replace the 0 by 1. And they store them, which is only one address. They store that one in the data output file. So for them now, the data output file, it takes only whatever in the last rank. Okay? Any question regarding the last rank one?
بس هي practically مش هيك بتصير.
How it happens in practice?
إنه إذا عم تعملها relays يعني in real life.
Yeah, what it happens, a relay. No, this is a LAD program connected to PLC. This is a LAD program. So here means here you have input module of your PLC, and here you have the output module interface of your PLC, and you are connecting to it switch chain, two switches, and here is the LED 1, and inside here you write your program. Okay, let me write in different colors. That's my program. Switch 1 and switch 2. So both have same address, LED1, LED1. So that's your program which you loaded to the processor of the PLC. That's the program that you loaded to the processor, and you give switch 1 this address and switch 2 this address, and those share the same address. So, and because the execution of the program coming this way, reading the data input, and at the end storing the result of the logic operation at the data output file. So always the data that will be stored here, so anything it was stored before, it will be override by the rank which come after it. So the data output file will be overwritten by the rank that's coming after it. You get it, Hussam? Are you fine now with?
Yes, I understand.
So let's do this one. Let's do this one. So here, which of the two below coils is dominant? You have also two switches as the first problem, but here you have a set instruction, and here you have reset instruction. So we saw set reset in your lab, practical lab last time, and also in the lecture last week. We saw this instruction. This is latch, and this is unlatch. Okay, set and reset is like the instruction you saw in your course, latch and unlatch. In some, like in Siemens, they call it in Siemens programming, they call it reset, but it's exactly the same as what you learn in your software. And unlatch, they call it latch, they call it set. So okay, they name it S instead of L. Here they name it R instead of U. but it's the same. So here, which of the two below coil is dominant? So here they have the same address. It's LED1 and LED1, and you have two switches. So exactly same exercise, but instead of putting just energize if on, so we are putting set and reset instruction. Let's take the fourth scenario. Okay, so we have four scenario, but here you need to be aware that it's not only switches, right? Because it should save the state. Here it's set and reset. Yeah. So here how to which
Doctor, we can say that the output is energized just if the first switch is on and the second switch is off. The three other cases will be off. I think either
yeah.
both switches are on.
Yeah, let's see if that's the question is correct to write it this way. They said which of the two below coil is dominant. So that means the answer should be, is it rank 1 or rank 2, if you wish. Is it the reset? Sorry, is it the set coil or the reset coil will be dominant? So I expect from you an answer saying the set coil will be dominant, the reset coil will be dominant. That's
The reset.
okay. So this problem set and reset. If I go to here,
دكتور البروبلم قبله ما كان set and reset.
no, it was simple instruction without set and reset, right? It was like this. That's the previous problem. Now our problem is different. Our problem is set reset. So, but exactly same, but you are putting latch and unlatch. So now I download the problem and I run it. So what will happen if I'm pressing switch 1 will be on, the light will be yellow, on. So what happens if I switch 1 off?
It stays on.
It stays on. Good. Nothing will happen again. So what if I press switch 2, so it will be unlatched. So now it's unlatched. What if I press switch 1? Nothing will happen, because the last rank will win. So then always the last rank will win. You can see last rank is win, because the last rank is here, the result of the logic operation is 1. Therefore, for any situation, the LED1 will be unlatched, will be off.
بس هي أول شيء initially كمان first rank.
First rank what? Yes, Tony, if it's first rank is what?
When the switch 1.
Your voice is interrupting. If you wish, you can write the question. So sorry, Tony. Tony, unable to hear you well. If you wish, write your question. I'm so sorry. Do you want to write your question? Tony, hello. Hello. Okay. So I'm not sure if you heard Tony question, you understood on him. Is there anybody understood what he was asking? Heard him?
No, doctor. His voice was not good.
It means that when the switch 1 is on, the latch turned on. Yeah, when switch 1 is on, the latch, look, that's the situation you are talking about. When switch 1 is on, the latch is on. That's right. But now when I go and turn the switch 2 on, I close my switch 2, what will happen now, Tony? What do you think will happen if I close my switch
It will
2?
turn off. It
It will turn off. It will turn off. Yes, because it's unlatched. So then always
Yes.
the last triangle will win. This you need to pay attention on it on a big problems later on. So always if it happens that you need to use the same address 2 or 3 times in your big problem, so you need to be aware about this situation. Okay. So it is on, okay, because now the switch 2 is not, this switch is still up. When I close it, then the last triangle win. Is it clear? So last triangle when I write it this way,
Yes.
last rank will win. Okay. So we'll do the same problem, but with reset and set. So what do you think? Which rank will win? According to the
Last rank.
according to the rule, just
Second round.
keep the rule in mind. Last rank will always win. Okay, so let's test it. Here we go. Then so this is set reset, and this is reset set. Okay, that's the problem. So now, if my switch 1 is on, nothing will happen. I am not in a run mode yet. Okay. If switch 1 is on,
دكتور بس بعد
Tony,
يس عم بقول انه هذا الكيس باللاتش والانلاتش بعدك.
yes, but here I have unlatch then latch, right? Is it?
Yes.
Let's see the problem how it is. So first I have latch and unlatch. Here I have unlatch then latch. Just I switched them.
Yes. Yes.
Okay, so now I have first unlatch then latch. So if I turn on switch 2, what will happen?
It will turn on.
It will turn on. Very nice. So even so, if my switch 1 is on, even if my switch 1 is on, so I am saying to my LED 1 to be unlatched, but it doesn't. It follows the instruction from switch 2. So that's why switch 2 will rank. Unless if now if I turn off my switch 2, still latched, unless if I unlatch it. Okay, so that's because I allowed it to be unlatched, because switch 2 is not on. But if a switch 2 is on, even if I say latch, unlatch, it doesn't unlatch, it doesn't reset, it's still set. Clear the problem?
Yeah, to turn it off, we must close the switch 2, then close the switch 1.
To turn it off, you must open, you mean?
Sorry,
Yeah.
open switch
Yeah.
2, then switch 1.
Right. You must open switch 2, then turn on switch 1.
Turn on, yes. Turn on
Yeah.
switch 1.
Because when you turn it on, you unlatch it. So now if I open this, and this is because it's on now. Okay, so we are in this situation, still on. If you close switch 1, it will be unlatched. Any question regarding those exercises? Which rank will win? Basically, this is practice, a bit practice about which rank will win. So in a scenario when we have normal output or set reset output, and in the those are. Any question regarding
No, doctor.
this row x3 exercises? And we learned also today the interlock problem. This is keep in mind. Interlock problem is. Did we try the interlock problem together? Yes. Did we try the interlock problem together or not?
دكتور أنا في
Yes, doctor. Interlock الأول.
This is we didn't try together, I believe, right?
This one, no. بس عم بحكي عن first exercise.
Latch and unlatch, yes. So this is the interlock that I was talking about it with you here. Keep in mind, this is also something that may happen if you have two incompatible events. You don't want them to occur at the same time, so you do your problem this way. The LED 2 go as an instruction in the rank of LED 1, and LED 1 go in the instruction of the rank 2, as we explained it before. Later on, we see other things. Okay, so let's download the problem and run it. So look, if I want my switch 1 to be my LED 1 to be on, now it is on. If I go and I want my LED to be on, it will never happen because LED 1 is on. Only if my LED off and I turn my switch 2, then it will be on. Now this is on. If I want LED 1 to be on, it will never happen because LED 2 is already on. Alright, any question regarding the interlock problem?
No, doctor.
Good. Now I'll switch with you to analog scaling in the remaining time. A bit about analog scaling. Okay. I will share this document with you. Share. Okay, let's wait. I'm not sure. So in this document you have my link, which you may saw it before. I'm not going to start by it because it has more than the information regarding the analog. So this video I'm recorded myself time away in chapter 2. It has more than analog, more than talking about analog. Also, I was talking about connection of input and output. You could look at it. So we'll start from here. So here you have two links. You can go over them yourself because I'm posting. Okay, because don't lose time, I'll post it at the end of the session. Okay. We are in week 5. I posted. Okay. So then now if you go to week 5, you should be able to see it. It is here. Anyway, so you can go over the links. So talk about analog scaling. So here I have a water tank. This water tank is connected to a level sensor in which you are measuring. You need at the end to know the level of the water tank. How liter I have, how many liter I have. So the level sensor, it gives you, assuming in this situation it's an analog sensor, it may give you voltage output or current output. Okay, in this scenario is giving me current output. So it gives me 4 to 20 milliampere signal, and this 4 to 20 milliampere should be relative to some level meter, like in a previous video for me, like I was maybe a gallon per meter or some other unit. Like 4, it corresponds to 0. If my output is 4, corresponds to 0 gallon. If my output is 20, maybe corresponds to 200 gallon per meter. Okay, so you can do scaling this way. So understand, then it depends on how many current you have. You can conclude how many gallon per meter you have. Or in this problem, this is simpler problem here, you can understand how many liter you have in your tank. So got 4 to 20 milliampere signal at the analog input card. So here you have an analog input card in your PLC, analog input interface. So what will happen later on in this analog input card? The 4 to 20 milliampere analog signal, the analog input card is somehow, as we said, similar to analog to digital converter, as we said in chapter 2. It is an analog to digital converter. So it will convert it to a digital signal, right? It will convert your analog signal to digital signal, so to 0, 1. That's what will happen. Usually, if it is 16-bit resolution converter, which is the most often used, if it's 16-bit, they save 1 bit for signing the number. Like if your signal is positive and negative, so they save 1 bit for the sign, assuming your signal not 4 to 20 milliampere, assuming it is minus 5 to 5 volt, or minus 10 milliampere to 10 milliampere also. So then you need to save some bit to indicate that it's a negative value. Then the remaining you have 15 bit. So if it's 15 bit, 15 bits corresponds to how much? How much in decimal? You need to compute 2 to the power 15, right? 2 to the power 15, 3 to 7, 6, 8. 3 to 7, 6, 8, okay? Then, if it is the sign is 0, conventionally we consider it as positive. And if it is negative 1, we say it's a negative number. So it means now I can count between minus 3 to 7, 6, 8, up to 3 to 7, 6, 7. Why 6, 7, not 6, 8?
Because there's 0.
There is 0, so 0 we consider it. 3 to 7, 6, 8. Okay. So yeah. So then represent value from this to this, from minus 3768 to 767. All right. And this is assuming I'm taking a signal minus 10 milliampere to 10 milliampere, then this one corresponds to minus 10 milliampere, and this corresponds to 10 milliampere. Of course, this is the decimal equivalent of your digit, because we are human, understand more decimal base, so they put for us in decimal, but this is you convert it to it is in binary, written in binary, which corresponds to minus 10 milliampere, assuming it's negative, 10 milliampere if it's positive. Or, so yeah, if your signal is only positive, you may decide to take the 16 digit, and then you improve your resolution. You improve your resolution. A time here, I was talking about resolution, okay, in my video. Like assuming you have a signal from 4 to 20 milliampere, so this is 16 milliampere range. So if your converter is 12 bit, only 12 bit, not 16 bit, assuming. So 12 bit is 2 to the power 12, and if you are taking all, like just considering positive or so then your resolution is the step, the smallest step. Then it is the range that you have, which is 20 minus 4, means 16, over 2 to the power 12. You get your resolution. Here I was giving the example, if you have 16 milliampere, if you have 4-bit resolution. So if you have 4-bit resolution, like if you are taking your signal, in each cycle you are taking 4 to 5 point, for example. If you have more resolution, so you will be having maybe more, step. So you can even detect the smallest step possible. Okay. Because you have the link, so I believe you can go and explore more. This link, some YouTube, you can look at them, and still have 5 minutes, but Wednesday we'll continue on analog scaling. Here is, they continue like this, the level in letters, it will determine level of tank and letter. So, level transmitter actually transmit signal in the form of 4 to 20 milliampere to the module. That's what we was saying in a while. Then an analog input module converted to voltage, and this voltage will be converted to digit, assuming 0 for 4 milliampere, and for 20 milliampere we get 65535, assuming it's 16 bit and your signal is 4 milliampere to 20 milliampere. So then the 4 milliampere corresponds to 0. The 20 milliampere, if it's 16 bit conversion, the highest resolution is, for the 16 bit, 2 to the power 16 equal to 65535. 2 to the power.
آخرها 6. طب
So 65536. 65536. 65
minus 1 لأنه مبلش
536. So then here should be, yes, Haider, bravo. So 65535, because we start by 0. So from 0 to 65535, it is 65536. So then if 4 milliampere I give it 0, I can give the 20 milliampere the highest number, assuming I know it is positive. So then I don't take a signed convention. That's in general. But usually, how the analog to digital, sometimes you cannot control it yourself. It's coming programmed in a way that the highest value they give it the 3 to something, the 2 to the power 15 minus 1, because they take into consideration it may, a general case, you may have a negative signal. Okay. Also, what Siemens they do, it's even better than that. They don't only take a scenario in which you have a negative signal, so they give a signed bit for the negative signal. In addition to they save a bit for the negative signal, Siemens they save some bit for overflow and underflow, or overshoot and underflow. Like the signal is between 4 milliampere to 20 milliampere. What if you had a like short circuit or so, and your signal coming from the sensor is more than 20 milliampere? So able to know it? Yes. So they save some bits for overcurrent, if you wish, and also some bit for less than 4 milliampere. So then they don't assign 2 to the power 16 or to the power 15 minus 1 to the 20 milliampere, as I said in a while. 2 to the power 15 minus 1 and 0 to this, okay. And of course you have the negative, so they can assign. So look what they do. Siemens, for example, they assign this decimal number, which has an equivalent on binary, of course, on an hexadecimal or whatever. So they assign this bit for the 10, well, for the 20 milliampere. We are in this talking about 4 milliampere to 20 milliampere. So they assign this value. And if it is less than 4 milliampere, if it is more than 20, like assuming it is 22 point something, they assign this value for it. If it is this overshoot range, overflow range, they assign then the 32767, which was talking about the 2 to the power 15 minus 1. They assign it here. So they give some range for overflow. So you have overflow. Okay. So assuming you are controlling your signal and then it overshoot, and so then they give some range, some bits, and your controller, your process doesn't go crazy because it has some, it can read overflow or underflow as well, like here. If it is less than 4 milliampere, they assign to it some negative number, because we know it is from 32767 up to 32768. 327, if I'm not wrong, right? 2 to the power 15 minus 1. 32768. If it is 16-bit. So they have, which is a good thing, as to have overflow and underflow. See this underflow. So they do this. So then if it is the current lower than expected, so they can detect it for a reason. Maybe you need it. Okay. We're done. I don't want to take more from your time. We'll continue next time. So I was here. In this scenario, they just take it the full range as a positive. They don't have overflow, they don't have underflow, they don't have a negative sign. If you are in this scenario, then you can assign the full bit to your signal as they are talking here. We are following their YouTube, so you can follow it. Next time we'll start from here, okay? Next Wednesday. Do you have any question about just started at analog scaling? We'll understand, becomes more clear next time. If no question, يعطيكم العافية guys.